Okay, so it says just recording. Okay, I'm going to start up here with a screen share. So let me get that set up for you. Hopefully everybody can see a map in front of you. So what that map has is all of the water testing sites set up or identified in Story County as part of the water monitoring program. So there of those sites, there are 13 of those sites which are monitored by staff, Story County Conservation Board staff. 2 of those are lakes. One is Dakins Lake up here by Zeering, and the other one is Peterson Park down here, north of Ames. Trying to find my way on the map here, get a little confused. There it is. There's Peterson Park at the deepest spot there. So when you look at this map, all the black dots are assigned sites. They currently have volunteers at them or staff. So we have 13 monitored by staff, 22 that are monitored by 17 different individuals in one business. We have a business that has a team of people that work together. I'm happy to see some of these assigned sites. I got monitors that are participating in this today, so thank you. There are 6 sites on here that were previously set up but have become inactive because either the volunteers either didn't start or started and then had to withdraw from the program. And then there's 3 sites which are waiting to be set up starting in 2022 season. So when you look at this again, black dots are assigned sites. We have somebody at them. The red and yellow are various level, high, medium, and green is low. Those are sites that we've identified that we want monitors at, but I do not have someone assigned to. The white spots are other sites. There may be a data being collected by somebody else, and so we just wanted them on the map to know that somebody else is monitoring in those areas. So that's why they're marked as other in the key. So you can see that we have a site in every plant for every Huck 12 hydrological unit code in Story County. We did decide, part of it was because of stream levels, part of it was because I know people are running out of equipment. We ended our 2021 testing season in October. We are asking that all volunteers return their kits to Story County Conservation Center at McFarland Park so that we can go through those kits and get them ready for next year. Also, if you could report your volunteer hours through service, because we want to keep track of how much time volunteers have spent doing the monitoring throughout the year. If you have any questions about that, you can contact Erica Place, our outreach coordinator. Her email is eplace@storycountyiowa.gov. When you drop off your kit, we are encouraging you to get involved with the Isaac Walton League Salt Watch program, which monitors road salts in waterways, and you can do that anywhere near where you live. That necessarily doesn't have to be at one of your assigned sites. So if you're currently a non-volunteer that's watching this and you want a salt watch kit, you can go out to Isaac Walton League website and ask for one. And last but not least, I want to introduce Sarah Carmichael's on here. And see if I can turn off this screen share. She will be taking over the water monitoring program. She is our watershed coordinator here in Story County Conservation. And I am bowing out of the program, just providing background support, and she will be your new face and contact. So Sarah, if there's anything that you'd like to add.
Yeah, thanks, Jerry. Just, kind of introducing myself to you all. I hope to meet you all in person one day. We will start up the 2022 season sometime February, March. I'll have you all come pick up your new water monitoring kits. We're going to kind of revamp them and get some backpacks and some safety vests. So we're excited to kind of expand that. depending on COVID and how we all feel in the winter time, we'll see if we can maybe have a large gathering, get together, so that you can pick up your kits and meet other volunteers. But to be determined, and just look for emails from me, and we'll go from there.
So Dan, that brings us to what did the data that all the volunteers and staff collected this summer tell us? What can you synopsis out of all of it?
Sure, and I will show that in a minute. And one of the sites I want to highlight is one that has been monitored by Steve Junks. So I wanted to have one of our regular volunteers talk a little bit about his experience for the benefit of those who are just getting started or who are thinking about doing volunteer monitoring. So Steve, can you tell us what site you monitor and how you got started with it?
Sure. I monitor on West Indian Creek. On that map that was up a little bit ago, I was the first black dot south of Nevada, south of Highway 30. The spot that I monitor is right in the middle of our property, so it's relatively easy for me to get to, at least during the spring, summer, and fall. Winter, the snow prevents me from getting down there because of the buildup along our west fence. But I started in October of last year. Monitored until it got too cold or too snowy, I don't remember which, to go down there, and then started up again this spring, and have been fairly consistent with the exception of a couple of recent trips that we've taken. I had been curious about the water quality down there since we moved here in 1996. If you're familiar with West Indian Creek, as it's just south of Highway 30 there, it's also just south of the sewage treatment facility at Nevada, and they discharge back into the stream. I'm assuming they discharge fairly clean water, but I've also noticed a lot of algae buildup over the years down there. So that was the main reason for getting started, was to answer some questions that I had about water quality as it flowed through our property.
And what was the learning curve like? Was there, had you done water monitoring before, and how easy was it to get started?
No, I had never done any water monitoring, so it was brand new to me. I'm not doing any of the biological, it's strictly the chemical portion of the monitoring. That was really pretty simple. It started out kind of slow. It would take me 45 minutes or so the first few times that I did it, because of having to read the instructions for each step in there each time I did it. I've gotten fairly comfortable with that now. So given the fact that it's so close to where I end up recording the data, I can usually do the sample from the time I leave the house until I'm done entering data. It's usually 45 minutes or so. The actual sampling in the stream, maybe 20 minutes, 25 minutes, something like that. So not difficult to learn. The piece that I struggle with a little bit is matching colors or hues on the oxygen levels and the potassium levels. There are a number of vials that, at least to my eyes, don't change very much in between. So I sometimes question whether I'm getting the right number, but I just bull.
I think that's, Steve, I think that's a universal experience. I know when we do bigger volunteer monitoring events, there's always a lot of passing it back and forth. And did you get, which one did you get? So, and that's often helpful to, the first time you're doing it, to test with a partner and see if you're getting the same thing. So, and then how are you finding the experience? What are you getting out of it?
What am I getting out of it?
Mm-hmm.
Well, it's essentially more or less confirming what I suspected from we have lived out here since 1996. And I had often suspected that the water quality was not terribly good. Indian Creek from here on south runs primarily through wooded land. As you get north of Nevada, it's a much smaller stream up there, but it runs primarily through ag land. So I'm not sure whether the quality that I'm seeing is a result of ag drainage or sewage treatment plant drainage, but it's not a pristine stream. And it was, I guess that was, I don't know whether comforting was the right word, but it sort of confirmed what I suspected.
Yes, and I'll be showing some data that can help dig into that a little bit more. Have you been seeing wildlife when you're out there? That's one thing I enjoy about water testing, is that as I've gone out on a monthly basis to my sites, seeing the bullfrogs progress from tadpoles to things with legs and a tail to full-grown frogs. So are you seeing any wildlife?
Not that kind of wildlife. When we first moved in out here, I was hopeful that I would find smallmouth in bass in the stream. And I fished it maybe 5 or 6 times over the years, and no smallmouth. There are creek chubs in there. It's about the only thing that I've ever caught. I now have some pretty active beavers that have decided to build a dam just south of where I sample at. And I'm actually sampling at a low water crossing on my property, and it's not quite as low a water now that they've built the beaver dam. So aquatic wildlife, no, not much, but deer and turkeys and pheasants and all that sort of stuff as I drive down there. So.
Okay. So I will get going with sharing some of the data we found. Is this showing up right, that you're seeing the full screen?
Dan, it's actually showing your next slide. I don't know if there is a way to change that.
How about this?
There you go.
Okay, thank you. The way I'm going to do this is for each of the parameters that we have volunteers measure, just remind you of how that's done, and jump in, and Jerry can jump in if there's any reminders for things that we've been seeing people struggle with, or tips for how to do it right. I'm going to show you a little summary of 2021 as of October 28th, when I've downloaded the data. So what we're seeing, typical and atypical results across sites. If you've so this should be most people, but if you're monitored in late October and haven't gotten that data in yet, then we'll be missing you. But I'll get that updated in our final report, but this should be pretty current. Then I'm going to show you Steve's site on West Indian Creek, because this is one that really stood out as being kind of unusual and helped us make sense of some of the bigger patterns we were seeing. And then I'm going to be, and then I'll bring in some additional data sources, because we have a wealth of data from various agencies, as well as local partners, that we can look at to help make sense of the patterns that our volunteers are seeing the benefit of volunteer monitoring is it can cover a lot of sites that have never been studied, but then we also have some data that goes in a little bit in depth, or is monitored more frequently, that can help us make sense of what we're seeing. If you have questions about when I'm covering phosphate, if you have questions about phosphate or comments about it, feel free to jump in at the end of the segment. Otherwise, we'll try to leave some time at the end for discussion of general discussion and questions about the monitoring program in general. Temperature. We've had folks out there in the heat of summer and the depths of winter measuring water temperature from 0 to 32 degrees Celsius. Typical, I'm using the median here. So if you rank all the data from high to low, which one's in the middle, median is 21 degrees Celsius, or around 70 degrees Fahrenheit. And then looking at differences in sites, South Skunk was very cold. West Indian Creek, very warm. And if this seems strange to you, it did to me, and I took a closer look. So here we have the South Skunk River at 290th was monitored from January through June, and West Indian Creek at Heritage Area was monitored through July through October. So that's why West Indian, that site was warmer on average. So this is a problem that we often run into with volunteer data, that people are starting and stopping, and that's fine. We want to get people involved, and people's schedules don't often cooperate, but it does pose a little bit of a challenge when analyzing the data. Are you actually seeing differences in sites, or is it differences in when things were monitored? So here's temperature at Steve's site. Any observations, Steve, about the kinds of weather you were encountering this year when you were monitoring?
Well, the weather this year has been hot. But my observation of Indian Creek is, at least at our location, it rarely freezes over completely. It's just a warm stream, and I attribute that to the sewage treatment facility. I think the water they return is probably fairly warm. But I've been down there the first time I was aware of how warm it stays. We had bought the property but hadn't moved out here. And one January 1st, I was out here deer hunting, shot a deer on the other side of the stream, and decided I could bring him back across the ice. And fortunately, the water was only about knee deep because I broke through the ice, even though it was 10 below. So it's just warm here all the time, no matter what the weather is. It did feel pretty cold this morning. I went down and did one final sampling, and it was 5 degrees Celsius this morning, so it's cooling right down, but it's unlikely that it'll freeze over anytime soon.
Yeah, and I've noticed that as well. I monitor, do lab testing at West Indian Creek at Janet Heritage area, as well as Grant Creek that also joins with it just below there. And Grant Creek often has been frozen over enough that I couldn't get through it with the ice auger, and West Indian Creek tends to stay flowing. Part of it is there's some riffles there, but yeah, definitely I think the warmer effluent from the wastewater treatment plant has some influence. One thing to be aware of, these are graphs from the Clean Water, Isaac Walton League's Clean Water Hub. So they do kind of an auto scaling here, and that sometimes obscures if there are gaps. So, here was during the depths of the winter, the site was not monitored, and so you'll want to be aware of that. Often we have that. Have some gaps in the data. Not every site is monitored on the same schedule. So here is phosphates. So reactive phosphate, orthophosphate, different names for the same thing. This is the dissolved form of phosphorus. And if you haven't done this before, we monitor it with ampules, these little glass vials. You add a drop of the activator solution, shake it up, put it in here, break it off, and it sucks up the water. You let the color develop, and then you make a comparison. And we have two ranges of vial. You'll start out with this one, hold it up to the lights, the low range. And most of the sites have been regularly seeing phosphate in the low range. So 0.6 milligrams per liter was typical. We've had some sites like Onion Creek where people have usually been finding phosphates nearly undetectable. But we have had some sites, of which Steve's site was the worst, where we were breaking out the high range comparison vials. So Steve's site had a median of 6 milligrams per liter. And there were some other sites as well that had were averaging on the high range. Jerry, any reminders or issues with how to test phosphate effectively?
Well, not necessarily the phosphate. You got to remember, you got to put those drops in there. We had some people that were not using the additives that go in there, and with all of the data that you enter, we ask that you find the closest number on the color scale and try not to go in between. So if it gives you a choice between like a 6 or 8 and you think it's in between, we ask that you not put a 7. We want to actually put what it shows, not try to extrapolate an answer. So find the closest color match.
And I just got some advice from Susan Heathcote, who's a trainer with the Saber Streams program, and what she recommends doing is err on the low side and interpret it as at least this much. So yeah, if it was in between 4 and 5, you put down 4 and interpret that as at least 4, because she was saying that people that helps kind of ensure consistency, that people tend to want to bump it up to the next level. So that's what we'd recommend doing. So here's Steve's site, West Indian Creek at South S below the wastewater treatment plant. So we've been consistently seeing phosphorus of between, I guess the lowest value here was 1 milligram per liter up to 9 milligrams per liter. Anything you want to say about phosphate, Steve?
Not really. I don't know whether I've gotten better at reading the values or whether it has become more consistent. I suspect the first 2 or 3 readings that you see there was me still in my learning curve more than variations.
Okay.
Dan, I would just like to throw out, I know you keep mentioning downstream from the water treatment facility, but we also keep in mind it is also downstream from the only real urban center up in that area. So, and instead of just always targeting on the wastewater treatment plant, it also is downstream from, Nevada itself. So.
Yes, and that's a good thing to keep in mind. I think I have some data to point to wastewater treatment as being an important source here, but yeah, in general, I think people tend to want to point to, if it's downstream of a wastewater treatment plant, point to that. If it's downstream of a hog confinement operation, point to that. But often water quality is going to be driven by the entire watershed, which in this case is, a good 50,000 acres of farmland and the city of Nevada. So it's good to think about that overall watershed, all that. There are many sources within that could be influencing water quality.
And I would just add, Dan, when you look at that phosphate, he was talking about his learning curve early. That might have been dilution factor from rain and water levels, where this summer we had pretty much no rain, no dilution of that. So I can see maybe that might be part of why he's got a little bit flatter numbers there.
Okay. Yeah. So, West Indian Creek, and I'd been doing lab testing a little bit further downstream and was wondering about what I was seeing. So this kind of, clued me in. It's something that maybe other people knew about, but that I think we weren't thinking about that much because we've been so focused on working with farmers in the watershed. So to really understand what was going on here, I have been taking advantage of this really rich data set from the city of Ames. They test above and below the wastewater treatment plants on the South Skunk River on a weekly basis, going back 18 years. So, mostly doing this to inform the operations of the wastewater plant and for compliance with the permit, but then it's also really useful if you want to look at trends in nutrient levels. So I have 18 years of weekly phosphorus data. I also have 18 years of flow data from a USGS gauge a little bit further upstream. I have put those together. So this is, if you take that 18 years of weekly data and you rank it from high flow on the left to low flow on the right, and then this is a percentile based approach. So, so high flows would be anything, the top 10%, the 10% highest flow days over that period. And so what we see here is that although phosphorus is a little bit higher under high flow conditions than in normal conditions, and we know that phosphorus attaches to soil and so moves with if you have erosion from farm fields or erosion to the stream bank, that can elevate phosphorus. What we really see below the wastewater treatment plant, below the Ames wastewater treatment plant on the South Skunk, is really high phosphorus levels under dry conditions or low flows. And so what's going on here is that the effluent has quite high phosphorus levels, almost 5 milligrams per liter. And the stream upstream of the wastewater treatment plant typically has very low phosphorus levels. And so when you get dry weather, that means the effluent coming in is less diluted, and we see the phosphorus concentration rise. So concentration is important from the perspective of a smallmouth bass in the stream or of algae in the stream. But when we're talking about the Iowa nutrient reduction strategy and hypoxia in the Gulf of Mexico, from a shrimp's perspective, what matters is the load of phosphorus that's delivered in terms of how many pounds per day of phosphorus is going downstream to the Gulf. So load is a combination of the flow of water in the stream and the concentration of phosphorus. So the analogy I like to make is you can, just like we're worried about impaired waters, you might be impaired by drinking a 6-pack of Keystone Light or a single, Imperial IPA. So it's, for human impairment, it's the strength of the drink and the number of drinks. For water, it is the concentration, the concentration of the pollutant and the volume of water moving downstream. So here's another way of showing the same information on a log scale. So we can see here really much more clearly, the tick marks are a 10-fold increase. So each time you go up is a factor of 10. So under a low flow day, about 40 pounds per day of phosphorus is moving downstream to the Gulf. On a high flow day, about 4,000 pounds. So this graph is called a load duration curve. The EPA uses this quite a bit. The Iowa DNR uses this quite a bit in developing cleanup plans and pollution budgets, because you can see what's happening under different flow conditions, and there are different things going on at different flow conditions. So we're seeing here that wastewater treatment plants are really important under low flow. Agricultural runoff and stream bank erosion are going to be bigger concern under high flow. Cattle in the stream, bigger concern in low flow conditions. So it can be really helpful to make sense of where pollutants are coming from and what's important in a given stream. Just want to jump in at this point and say there is some work that goes into analyzing this data. I did this using the statistical programming language R, and it took about 200 lines of code. You can do the same thing with spreadsheets and with databases, but it is like an 11-step process to get data from two sources, the USGS and your water quality data, get them working together, calculating loads and graphing it. So I just want to mention that because people often forget about the data analysis part and don't want to assume that someone else is going to do it and nobody actually does. So again, we have a little bit of an issue with people on different schedules. It does make it a little bit hard to compare sites. So, I was expecting to see very high average phosphorus levels at the South Skunk, below the Ames wastewater treatment plant with the volunteer data, but we don't quite see that because this site was only monitored through June in West Indian Creek. And it was monitored in the winter when I guess things were a little different conditions. So something to keep in mind, but here's a little map showing phosphorus, green being low, red being high. And so once you start looking for this, this year in particular, we've really been noticing it and realizing it. Oh, okay, yep, West Indian Creek, high phosphorus, downstream in Nevada, there's a wastewater treatment plant. A little bit lower upstream, yep, there's a wastewater treatment plant on Dye Creek near Colo. I think there's a campground and a trailer park. Yep, high phosphorus in Ballard Creek near Cambridge. That's downstream of the Huxley wastewater treatment plant. So this is, I think, driving a lot of the patterns we've been seeing this year, just because it's been such a dry year.
Yeah, and a question: are the two wastewater plants? Do they both use the same or similar processes, or are they very different in their treatment?
That is a question I don't know. Does anyone else happen to know what the process is for Nevada's wastewater treatment plant?
Are they both secondary treatment, for example, or is the one in Nevada only a primary treatment?
That I don't know. I'll follow up on that. One thing I do know is that both are going to be going through upgrades. So traditionally, wastewater treatment plants have been required to treat things like ammonia, which is toxic to fish. They're monitoring for and treating for organic solids that contribute use up oxygen. So chemical and biological oxygen demand is one thing that wastewater treatment plants monitor for. But up until recently, they weren't too concerned about nitrogen and phosphorus. That's changed, and now wastewater treatment plants are going to be required to make upgrades. I think most have gone through a feasibility study process. So Ames is going to be making a series of upgrades over, I think, the next 10 years. Nevada is building a new wastewater treatment plant that I think will be online within 5 years. And so that's going to include some additional processes that can remove some of that, some of the phosphorus in particular. Any other questions about phosphate? Okay, let's move on to nitrates. So nitrates, if you haven't done it before, is done with a test strip. You dip it in the water, let the color develop for 15 seconds, and then you compare. Compare here, and there's one comparison for nitrates and another for nitrites. Jerry, anything to say about testing?
Yeah, although our test for nitrate and nitrite, we only report the nitrate on iWater, on our program through the iWater, through the Save Our Stream program, sorry.
Nitrite is kind of short-lived in the environment, and so most of the time it's not detectable. I have seen higher levels after rain, but nitrite and ammonia, I think, kind of cycle together, and so sometimes if there's high ammonia in the water, like maybe manure runoff, you'll see high ammonia and high nitrites. So this year, most of our typical site has been excellent, very low nitrate levels. And our best sites, can't even pick out one because there was 9 of them that had a median of 0 milligrams per liter nitrate. This year is not typical, very dry. Our worst site, again, was Steve's site of West Indian Creek at South S, 10 milligrams per liter median nitrate, which is at the drinking water standard. And then here's Steve's site for nitrate was high in the last fall, low in the spring, and then got high over the summer. Anything you want to say about nitrate, Steve?
I guess I'm a little more confident in those readings. It's easier for me to match that nitrate strip than it is to match those vials. So, but it's definitely high. And
I haven't checked these particular dates, but I'm guessing that jump from red to green might be some rainfall. Oh yes, I think we did have some heavy rains in late August because I did some storm sampling on August 31st. So I bet that's what we're seeing there, is had very dry conditions and then dilution after the rain. Nitrate. I was kind of surprised to see Steve's readings because I've been doing lab testing at Janet Heritage area, 5 miles downstream in Nevada, and there have not been seeing very high nitrate levels, and we have some measurements on the same day from here's volunteer testing. Apparently nitrate, by the time it makes it downstream, has been removed, and there are denitrifying bacteria in stream bed sediments that can remove nitrate from the water, and that's how wetlands work. Slowing down the water and getting that microbial activity going. And so that's more of that can happen under when there's a small volume of water. To put this into perspective, it's helpful to look at some real-time nitrate sensors that we have access to. The University of Iowa Hydroscience and Engineering has a fleet of nitrate sensors around the state. There is a system where you can look up real-time data, Iowa Water Quality Information System, and we have 3 sites in Story County, including one on Iowa Creek, just north of Ames. And so this can help kind of understand what's going on. Here's nitrate in 2021, and this year it was very low most of the year, except for we had some heavy rains in late May, and then the tiles started flowing again. The agricultural drainage tiles saw nitrate go up and then gradually go down as conditions got drier through the month of June. And now we're seeing it pick up again late October with those heavy rains that we had recently. Most years, so here we can compare stream flow or discharge and nitrate. Very similar. There were some smaller storms that we had during the summer. It seemed like, we weren't seeing much change in the South Skunk River after those rains. That the soils were just so dry that we're soaking it up. We weren't seeing any tile drainage or runoff coming in from upstream, mostly just urban runoff. And so nitrate wasn't changing very much then. Most years much wetter than 2021. So here's 2018 versus 2021. 2018 was also notable for having a lot of rain in late summer and fall. And so if we compare nitrate between those 2 years, nitrate was high and sometimes exceeding 10 milligrams per liter through much of the year, including the fall. So I think this year is going to be a little bit atypical. And one thing that we have seen is that after a dry year, there's some nitrogen left over in the soil that the crop wasn't able to use. And so in a wet spring after a dry summer, we may see very high nitrate levels next year. Questions about nitrogen or nitrates?
I have a question regarding nitrate after fall application, either of manure or of ammonia that they knife into the ground. Are you seeing concurrent, increases in streams with those applications, or are you able to track that at all?
I have not seen that. So, like here we saw, a spike of nitrate in 2018 in late August, early September, and I think the application would be happening in late October and November. So yeah, I guess we're not seeing that, and it may be that the rains didn't happen at that time, but I think more generally, nitrogen changes forms readily. So whether you apply it as manure or apply it as anhydrous ammonia, microbial activity is going to be changing that into different forms. Nitrate is the most soluble form, and that can take some time to make its way to streams, either through drainage tile systems or through shallow groundwater. And so we do tend to see lower nitrate in the summer, partly because it's drier in the summer, partly because crops are taking up the available nitrogen. But it seems like we don't see that strong seasonal pattern because so much of the nitrate is moving through slow paths, and so you might be some of the nitrate that's reaching the stream now may have leached out of the root zone last summer or last fall, and so there's moving at different speeds, and that kind of smooths things out a little bit. Other questions about nitrogen? Okay, dissolved oxygen. This is another one where we use the color comparisons and those ampules. We measure it on the data sheet as milligrams per liter, and then do a temperature adjustment. There's a chart on the back of the data sheet that you then convert it to percent saturation. And dissolved oxygen can become supersaturated. So that much like a carbonated beverage, you can get more carbon dioxide in the water than would be present under equilibrium. So most of our sites have been very high, 90% dissolved saturation for dissolved oxygen. South Skunk River has had very good dissolved oxygen. Our worst site again is a different West Indian Creek site. This one is near the headwaters of West Indian Creek at 180th Street. Jerry, any tips for dissolved oxygen or issues that we've been seeing?
Actually, Don, I consider it one of the easier tests to complete and one of the hardest tests to read. I agree with Steve on that.
All right, and here is dissolved oxygen at Steve's site on West Indian Creek. Steve, any thoughts on dissolved oxygen? Looks like we had some going into the poor range in November, in late April, and July.
Hey, Dan, I did think
Yeah.
of something to add.
Sure.
For dissolved oxygen, it's really important that the monitors establish a time of day and try and do that each time about the same time of the day, because I know that dissolved oxygen can change a lot from the morning to the evening in a stream. So it's not so much the day of the week, but if you started around 3 o'clock, always try and be close to around that 3 o'clock time whenever you test. Would you agree to that, Dan?
I would agree. Yeah, here's some real-time oxygen data from some sensors around the state. We don't have any in Story County. I'd like to get one, but here's several, and you can see there's a big swing during the course of the day. So in late afternoon, when the plants and the algae are photosynthesizing, oxygen is going to go up in the stream, and then overnight, when they're no longer photosynthesizing, when respiration and decomposition is going on, then it'll drop down. So the size of that swing can vary. So here we have one creek where it was a 3 milligram per liter in one day swing, another in 2 milligram per liter. Some of our bigger rivers, you don't see that as much. Here's the Missouri River, very small swings in dissolved oxygen. But yeah, that's why it's important to be consistent. If you can, that will help us get more apples to apples comparisons. Let's see. We did some invertebrate monitoring of West Indian Creek at Janet Heritage area. Got poor readings in 2019 and 2021. It got a little bit worse. We lost mayflies from the sample, and it was mostly net spinning caddisflies left in 2021. So, and those are mayflies have external gills. Some other bugs have a tube that they can kind of use as a snorkel and get water out of the air, but mayflies depend on oxygen in the water. So if we're thinking about what's going on with aquatic life, one possible explanation for like why mayflies suffered would be you get high phosphorus in the stream from the wastewater treatment plant, less diluted this year, so higher levels get more algae blooms. Then overnight, as that algae decomposes or is respiring, dissolved oxygen in the water gets used up, and then when dissolved oxygen gets low enough, as we saw in that creek, then we're losing some of the more sensitive organisms. So that's one possible explanation. I took a look at some lab data from the Iowa DNR, has measured chlorophyll, the green stuff in plants and algae at 2 locations on the South Skunk River, and I was curious if there was any correlation over the 14-year period when both sites were monitored. And on any particular day, we do not see any correlation. And this kind of matches up what I just have been noticing around the county, that like saw very big algae blooms this year in Iowa Creek. I've never measured high phosphorus in Iowa Creek at the times when I'm seeing it. One possibility is that, if you had high phosphorus earlier in the season, you're building up the algae over time, and now that the water levels drop down, we're noticing it more. So I did also look at phosphorus on the x-axis and chlorophyll on the y-axis for the whole season. So these the triangles are the South Skunk River at Sleepy Hollow axis. The dots are South Skunk River below the Ames wastewater treatment plant. A little bit more of a pattern here. We do see some higher chlorophyll when we see higher phosphate, but not that strong. So this is if you're a teacher and you've been wanting to have your class do some comparisons of invertebrates and dissolved oxygen and phosphorus, I would recommend against it because it's really hard to see a pattern. And, this may be something where if we get more consistent about time of day or can do some better controlling for that in the analysis, that maybe something will pop out. But I know DNR has done some studies as well, and streams just get a lot more complicated than lakes because you have the influence of tree cover and various other things added to the mix. Questions about oxygen? Okay, transparency. Transparency is done with this tube. And we have seen measurements. You fill it up and gradually let out the water until you can see the pattern. That's the bottom of the tube, the Secchi disc. So kind of similar to like the white sneaker test, wading out in the water and can you still see your sneakers? And we've seen quite a range from 5 centimeters to maxing out the tube. I think the Saber Streams program must have originally used a larger size tube because they have 65 centimeters as the cutoff for excellence, and we're only measuring up to 60 centimeters. So if you don't see any green at your site, that's why. We got a little bit of a mismatch there. Most of our sites this year were very clear. Again, because it was dry, we're not moving as much sediment in the water. The one site that was especially poor was West Indian Creek at Carroll Prairie. I'm not sure what's going on at that site, if the stream banks there are unstable, if there's cattle upstream, or if there was an issue with data collection. One thing we want to be sure of when we're measuring transparency is not to be stirring up the sediment when you're collecting it, and not to be sampling downstream of someone else who's sampling other things. Jerry, anything you want to add?
No, but I believe there's some sites, I think that site may have had some animal damming activity, and then of course swimming in the water, beavers, so that may be part of the water quality issue there. Okay. As far as clarity. One of the things we would like to do, I tried to earlier this year, work with Isaac Walton League to see if we can get a 60 plus, because right now you can only enter numbers, and I would like to get them to see if they can allow us to put a 60 plus if your clarity tube is maxed out. So we'll watch for that. Hopefully next year we'll have it.
And here's transparency at Steve's site. The scale here has been kind of adjusted, so it's automatically, so it goes from 48 to 60. So it's stayed in the good range throughout the year. Steve, anything you want to add?
Well, it's certainly consistent. At the point where I sample, it's difficult to get a full tube of water. Actually, the water level is so low in there. But in this stretch of Indian Creek, it stays clear most of the time. The only time I see it get noticeably cloudy or really cloudy is after pretty significant rainfall.
And that's a good segue. After a big rainfall, water quality can change very quickly. This was in 2019. We had done a volunteer snapshot event testing a bunch of streams. Most of them were very clear, including Clear Creek. We had a rainstorm a week later. Rick Dietz had the presence of mind to run out and take another sample. So in that 1 week span, because of that rain, it went from as clear as you can get to as muddy as you can get, down to 1 centimeter transparency, and from very low phosphate, 0.1 milligrams per liter, to very high phosphate, 5 milligrams per liter. That kind of cued me into this issue, and so I started being curious about, well, can we, most of the time when we're out on a regular basis, we're not going to be catching those storm events, but is there a way to get data from that? So I started using what's called a fixed stage storm sampler. These are made by Nalgene. Got a bunch for free from the Agricultural Research Service after a project wound up. Here is what they look like. there's a debris shield at the top, and there's a ball socket here. And so when the water, you set these up so that when water overtops the intake level, it will fill up and then it seals shut. That ball socket seals so that you're able to get a sample from when the water level was rising. So get a sample of stormwater without having to run out in the middle of a thunderstorm. So I've been experimenting with these the last year. This is the mounting hardware. So you can set these up to, like often I'll try to set it so that put them out a day before it rains. It's forecast to rain with the intake, maybe 4 to 6 inches above the water surface. I also have a Crest stage recorder pictured here. That PVC tube inside is the dowel and some ground up cork. So very low tech method, but when the water level rises, the cork sticks to the dowel and you can see how high the water level got. And so some of these I've been, taking lab samples in, but when the timing didn't work, I've tried volunteer kits as well. A few of the tests you can't really do with this because dissolved oxygen and temperature don't make a lot of sense if the water's been sitting in a bottle overnight. But the others I was able to test, so was seeing transparency a lot lower after a rainstorm, phosphate higher, nitrate generally about the same, and chloride lower. This, it'll be curious to see what people get if they're doing the winter salt watch this year, that we may see high chloride after snow melt or after a snowstorm, but during the spring and summer, it seems like chloride is coming in through the groundwater and then gets diluted by surface runoff. But this is something that we could, if people want to add on a little something to their monitoring site, this is something we could potentially do next year. I could get you set up with this hardware, and if you want to test the water quality after some storms. Questions about that? And then, I could come back to chloride and invertebrates if anybody wants, but maybe let's take some time here since we're at 1 o'clock if you need to get going. Thank you for joining us. And if you want to have further questions or comments about your experience monitoring, please jump in.
Yeah, I'd just like to say, I had kind of trouble. I was doing this myself, and I had a little trouble breaking those vials, and at the same time starting. I went out and bought a cheap stopwatch and trying to time that and break the vial at the same time. I found it kind of, sometimes the vial would break very high up above the little, there's a little mark on the vial I noticed at the tip. And I'm guessing that's where it should break. But very often trying to start the stopwatch and break the vial at the same time, it broke much higher, almost near the body of the vial. And I'm wondering if there's a problem in terms of getting a proper measurement.
I think that so long as it does break at all to the point where the water rushes into the tube and you are able to get some color change, I think that that should be all right. I don't.
Well, definitely the color changed, but I'm just wondering, especially also in terms of getting the time right. I mean, would it be better to break it, at the tip if I could, hold it and break the vial and then start the timer? I don't know how many seconds are lost and if it really makes a difference. Or
well, if I may add it, I know what I think I understand what you're asking, Kurt. So yeah, that few seconds that you're all are really not going to make a difference because by the time you start extrapolating it. What I have been doing though is I'll start my time, I'll get everything set and I'll start my timer, and then at the 15-second mark try and break it. So then I know I read it at 2 minutes and 15 seconds.
Okay, yeah, I didn't even.
So because it's a 2-minute wait. So I know what you're saying. You're trying to snap it and start your timer. start your timer and then break it at the 15-second mark and then read it at 2 minutes and 15.
Oh, okay. All right. All right, thank you.
And since both the dissolved oxygen and the phosphate have that 2-minute timer, sometimes what I'll do is run it for both. I'll get the activator set up. I'll get the ampules in both, and then hit the stopwatch, snap one, snap the others, and knowing that dissolved oxygen I did 15 seconds later. So then when my timer dings, okay, I'll read my phosphate and then I'll read my dissolved oxygen. I guess I wouldn't recommend that starting out, but once you get the hang of it, that can speed things up if you can do both of those. I guess the other thing is like I kind of jam it into the corner of the tube and then kind of press down on it. So not on the end, but kind of press down so that it's forcing it at an angle. That seemed to work well for me.
I'll also point out, in case you don't know it, but your kits, when you have them in the very front here, have a handy dandy area to lay your vial after you snap it and you're waiting 2 minutes. That's how you can do 2 at a time. There's a nice little pocket right here for you to lay it in while you're waiting your 2 minutes. Right there.
I know that. Okay, I actually do have another question, and this doesn't really have to do so much with the testing as just something that I noticed that I found kind of strange. One of my readings in September, I noticed as late as September, there were large polywogs in, like they look like for bullfrogs or something. That late in, I mean, do they take more than a year to develop? I mean, they didn't even have legs in September. And I'm wondering, what is it, because it's so warm, or it's just normal? Does anyone have any idea? Or
No, I've been, enjoying seeing bullfrog tadpoles as well as some smaller species especially at Sleepy Hollow. I've been noticing them. So I know I have some pictures. I'm gonna, now that you say that, I'm curious to take a look at when those were taken and what stage they were at. I'm guessing that maybe there was maybe there were multiple rounds of breeding that, if some of the frogs didn't. Okay, yeah. Okay,
So
you go ahead, Jerry.
just-
I don't know.
Yeah, that's fine. I just wanted to, so that Dan, he tests the Tedesco Environmental Learning Corridor inflow to location. So that's where Kurt is seeing it. So you're saying in the fall, you're seeing the big bullfrog tadpoles, the big green ones, right? I have a hard time understanding you, Kurt.
right, I'm sorry. Yeah, the big green ones. This is like middle of September, late September.
I can.
So I believe the bullfrogs have a 2-year life cycle.
Okay, so they would actually like hibernate and continue developing.
Right. Erica, is that correct? Do the bullfrogs do a 2-year life cycle?
Yes. Yep. They overwinter as tadpoles. So
Oh, I didn't know that. Okay.
yeah.
So what you're seeing is appropriate. You're
Okay.
seeing those
I
large
just thought it was a
1-year
loose one.
tadpoles that the following spring will turn into adults.
Oh, okay. They actually take longer, because normally I would think that they develop in one season. And okay.
Thanks, Erica.
You have a chat question from Jerry Neal about wondering if Whirly Creek has been being monitored. Is that one of the sites? would be sort of west of Tedesco.
I don't know of a Whirly Creek. I'm assuming they're referring to Whirl Creek. I know there's been some discrepancies on what its name is.
Right.
But there is a Whirl, WORRELL. It's sometimes referred to as Whirly. That's part of the Iowa Creek watershed. And yes, there are some test sites on that. The Tedesco Environmental Learning Corridor is a sub creek to Whirl Creek. Is that correct, Dan? Is there any other sites you can think of on there?
We do have a monthly monitoring test. Or we have a site where we, the city of Ames has been testing bacteria going back a long ways. Starting in 2020, we added nutrients and sediment to that. So yeah, we have a regular monitoring site on Whirly Creek. I think it is, it's located near the
Isn't that on
near the
16th
stadium.
Street? It's on 16th Street.
South 16th Street. Yeah, yep. We also have had several sites on Whirly Creek that have been part of the volunteer snapshots events, so have been monitored in May and again in October, going back over 12 years. So. So I think we're going to be doing a kickoff for the next monitoring season sometime in March. I guess when we do that, are there recommendations people would have, things you would like to see us address or improve that maybe you had trouble with initially and could use some more training on? Or?
Also, Sarah, why don't you put your email up in the chat, so that way too, if afterwards some of the current monitors come up with things, they can email you directly.
Yep, and we can send that question out through email. I know we're over time, so
yeah.
If anybody else has any other questions, feel free to reach out to me or Dan or Jerry. And,
I just have a quick question, Dan, or Sarah or Jerry, either one. I'm just wondering if there's any interest in adding bacterial sampling, particularly for E. coli. That used to be part of some, not all, but Iowa water monitoring, and certainly discovered in Ames here, famously discovered some of the sewage leaks done by a volunteer that discovered E. coli. Any interest in that? I know the protocol can be difficult for people.
Yes, I know what folks at the DNR told me was that they were having problems with consistency, that some people had kind of gotten the hang of it and were getting very good comparable results to the lab testing. So this was done with a ColiScan Easy Gel, I think was the product. So it was a plate and you had a styrofoam incubator. And so some people were getting good results with that. And Irv Klaas famously was able to find a sewer leak or a illicit discharge, I can't remember which, doing his regular monitoring at Iowa Creek near South Duff. But I think, more broadly, they were saying that a lot of people were having trouble with it and that they were getting inconsistency from person to person. So we are doing regular E. coli monitoring as part of our lab testing. We have 15 sites across the county that we're doing monthly lab testing, including E. coli. One of I haven't really compiled the 2021 data yet, but in 2020, what really stood out is how widespread a problem it was. That we had a few waters on the impaired list already for E. coli, but we were seeing that pretty much every stream we tested. I think the only site that met the standard in 2020 was the South Skunk at Sleepy Hollow. So E. coli is a very widespread problem. We're also doing some follow-up monitoring. We started working with a chemistry professor at Iowa State to test for optical brighteners, which are present in laundry detergent, and so are potentially a good indicator wastewater. And so I think we've done our second round of sampling for optical brighteners, and are trying to work out some of the kinks, because it is something that's can also be present in paper litter and other things in the environment. But it's, it's showing some promise that we're seeing some kind of differences where we expect them to, and so hopefully have some additional tools for narrowing down sources of E. coli. Yeah, I've been collecting samples for laboratory analysis of E. coli has also been part of the snapshot historically. So we have some good data going back for, looking at multiple sites on the same day and seeing where kind of the hot spots are.
And if I may piggyback on that, Jim, well, one thing we really are encouraging, the chemical monitoring testing is great, but it's a snapshot in time, specific date, specific time. We are trying to get people interested in doing macroinvertebrate testing, and hopefully we'll be setting up some trainings. We had one, or that will show more of the condition of the stream over a span of time based on the macroinvertebrates there. Those two things together can be used to help dictate where we're going to collect labs or tests to send to labs. So it's kind of like this volunteer monitoring chemical data. The macroinvertebrate stuff is the first level. But if we start seeing things that are kind of catching our eye, then we can set up sites for Dan and other people to go out and collect samples that we send to the lab. So it's kind of all connected.
Same question with microcystins too, Jerry. You think that would be people are seeing? Are they being taught about how to look for microcystins, at least visually at all? Blue greens.
I just did a blog post and an infographic this year, so I can send that out to the group of kind of typical green things in the water, and here's what blue-green algae, the potentially toxic stuff, looks like. The blue-green algae looks more like paint. The duckweed that we see often looks more like confetti, and then a filamentous green algae, also not harmful, looks kind of like a drain clog. So I have a little infographic with that I can send out. That's kind of a good starting point for what to look for. And I guess as far as where microcystins, I think I know that there has been some microcystin testing being done in Ada Hayden, since it is used as a kind of emergency drinking water source, and that's, I think, where we'd be especially concerned is I guess recreational lakes, and then waters that are used for drinking water. All right, we are at 1:18, so I think we better wrap this up. Thank you all for joining us, and thank you for being involved in water monitoring.
And thank you, Dan, for putting all those test results and making it so us lay people can understand all those numbers. And thank you, Steve, for sharing your experience as one of our monitors. Thank you.
Yes, thanks, Steve.
Yes.
Thank you. Yes.
Thanks, everyone.